filling of orbitals. In an atom, electrons are filled in orbitals according to certain rules. What are the rules? Alpha principle, Pauli's exclusion principle, and Hund's rule of maximum multiplicity. The first one, alpha principle. Alpha principle, then Pauli's exclusion principle, and the third one is Hund's rule of maximum multiplicity. Now let us discuss one by one. First one, alpha principle. First of all, the alpha is not the name of scientist. Here alpha is a German word and its meaning is building up. Its meaning is building up. So, the word alpha is not the name of the scientist. Right, what this rule says? In orbitals, electrons are filled according to the increasing energy. According to this alpha principle, electrons are filled in orbitals according to the energy of orbitals. That is, lower energy orbital is filled up first by the electrons and then the higher energy orbital. How to identify which is lower energy orbital and which is higher energy orbital? This is actually given by N plus L rule. What rule? N plus L rule. N plus L rule. Here N is principal quantum number and L is azimuthal quantum number. What this rule says? If you add the N and L value for a particular orbital, if the total value is less, it corresponds to lesser energy orbital. If the value is more, it corresponds to higher energy orbital. Let us discuss this with some orbitals. Take 1s orbital, 2s orbital, 2p, 3s, 3p, 3d, 4s, 4p, and 4d orbitals. Now, write the value of n for these orbitals. What is the value of n for 1s orbital? It is 1. What is the value of n for 2s orbital? It is 2. You know the number denoted before the orbital indicates the n value, isn't it? So, now you can write here 2, 3, 3, 3, 4, 4, 4. So, what these values? These are the values of n. Next, let us write the value of L, that is azimuthal quantum number. For s orbital, the value of L is 0. For any s orbital, the value of L is 0. So, put 0 here. Then, for p orbital, what is the value of L? Yes, it is 1. For p orbital, it is 1. What is the value of L for d orbital? D orbital, the value is 2. Now, add the n value and L value for all orbitals. Tell me the value. It is 1. For 2s orbital, it is 2. For 2p orbital, 3. Again 3, 4, 5. For 4s orbital, n plus L is 4 again. 5 and 6. So, I already told you, according to this n plus L rule, the orbital with lower n plus L value is lower energy orbital. So, now tell me, among these orbitals, in which orbital the n plus L value is very less? Yes, it is for 1s orbital. So, write the energy order. 1s orbital possess lower energy than which orbital? Yes, this 2 corresponds to 2s orbital. Then next, you can find 2 orbitals with the same n plus L value. Now, you can raise me a question. Here, 2 n plus L values are same, so which orbital is of lesser energy? If 2 orbitals are with same n plus L value, the orbital which possess lower n value corresponds to lower energy. Here which is possess lower energy? Yes, lower n value is for 2p orbital, hence 2p orbital possess lower energy. So, the next orbital is 2p, next one is 3s, then next higher energy orbital. Here you can find 2 values of n plus L of same value, 4 and 4, is it not? So, now you can tell me now which is lower energy orbital? Yes, it is 3p because the n value for 3p orbital is 3 and for 4s orbital is 4. So, the lower the n value, lower the energy. Hence, 3p orbital followed by 4s orbital. 3p orbital followed by 4s orbital. Then which comes next? You can find 2 values again, 5 and 5 of same n plus L value. Which is lower energy orbital? Yes, 3d orbital. Why? For 3d orbital, the value of n is 3, that is lower value. For 4p orbital, the n value is 4, which is higher energy orbital. So, 3d and 4p. 3d, next comes 4p. Then you can say easily 4d orbital is of higher energy than the other orbitals. In many competitive exams, you can expect a question as arrange the following orbitals in the increasing order of energy or decreasing order of energy. If you understand this n plus L rule clearly, you can easily answer for that type of questions. Next, let us move to Pauli's exclusion principle.